how many of you use one of these? Or watch one of these? And do you ever check the weather reports to decide what to wear the next day? All of these and many, many more things that we use every day are made possible because of one of these satellites in space. Right now, there are thousands of satellites in space that are being used to help us back here on Earth and help us understand space beyond Earth. But these satellites are expensive to build, and they are expensive to get into space. With all the changes in technology, is there a way to make satellites smaller, kind of like these cell phones got smaller? NASA scientists and engineers have begun to use these cute little satellites called CubeSats. CubeSats are much smaller than traditional satellites and way less expensive. A standard CubeSat size uses 1 unit, or 1U, measuring 10 by 10 by 10 centimeters and can weigh as little as 1 kilogram, while a traditional large satellite can weigh as much as 1,000 kilograms. An inexpensive traditional satellite would cost about $50 million to send to space, while CubeSats are small enough they could just hitch a ride. So 10 centimeters by 10 centimeters by 10 centimeters equals 1,000 cubic centimeters. Would that really fit in my hand?
I guess it depends on how large the size of your hand is. For example, look at this tissue box. This is the size of a 1U CubeSat. And here you deploy the antennas for communication. The 1U cube is just a building block for larger CubeSats. For example, this is a 3U CubeSat, and you can see 1, 2, 3. Again, 10 by 30 centimeters by 10 centimeters. There are also 6U CubeSats that are 20 by 30 by 10. A 3U is about the weight of a gallon of milk, about 9 pounds, and a 6U is the weight of an 18-pound bowling ball. You might be wondering, what are in these small little CubeSats? Well, let me show you with this little model that I have. You might have a sensor or an instrument that's really small, and you would also have what we call bus components. So command, data, and handling. We have a power system with a battery and also the solar panels that you can see here. There's also a communication system, and that controls the data that goes down as well as receiving commands that come up. And here is your antenna. The data that comes back from a CubeSat can actually be graphed, and you can measure differences. For example, before and after a solar flare, how bright is it?
It's clear CubeSats have some advantages over traditional satellites. If you want to see them in action, stay tuned for part 2. In the meantime, check out this website to find out more. See you soon!